Hello students, this is your professor Dr. Mink and welcome to another exciting lecture on Visual Basic. In this lecture we're going to cover the second half of chapter 3 and we're going to start with a very important topic, class level variables. And when we discuss class level variables we'll have to invariably discuss scope in depth. So let's get started. So, a variable that is declared inside a class, but not inside any particular procedure or outside all the procedures in that class, is a class level variable. Remember, we touched on scope earlier. Scope is the visibility or usability or accessibility of a variable within a program. And the scope of a class level variable is throughout all procedures in that class. So you want to take care when you're using class level variables because it can be more difficult to track down errors because many more statements or procedures can access that variable. So the scope of the variable is not isolated to a particular procedure. Therefore, the error, if it involves that class level variable, could be in one or more or multiple procedures. So you have to be aware of every statement that has access to a class level variables. However, class level variables are very useful. A special type of class level variable is a constant, a class level constant. And a constant is used when you do not want any procedure to be able to change the value. So for example, if you were doing scientific calculations and you declared a class level variable pi, which is a mathematic constant, 3.141597. I used to know it out to about 20 decimal places when I was a younger nerd. But anyway, so pi is never going to change. So you declare it with the const keyword at the class level. And those constants, class level constants, cannot be changed during runtime. So we want to declare class level variables at the beginning of the declaration of the class. So here we're declaring a public class Form1, and then we start to declare our class level variables. We start with a constant, a class level constant named int value. So there is the syntax for the declaration of a constant class level variable. Dim const, use the const keyword. You give the variable a name. In this particular case, it's an int value, and then as integer, and we're initializing it in the declaration to 0. You also see the declaration of a normal versus abnormal. Constants are not abnormal. Probably bad choice of words. But anyway, a traditional class level variable that is not a constant. Dim int value as integer, and we're not initializing that. Next topic is the content from section 3.7, exception handling. This deals with handling errors and how the program responds when either bad data is input or a bad calculation is made. Hang on, and we'll cover it in detail. Let's get started. We touched on runtime errors earlier, and we're going to spend a little bit more time discussing those now. So far, we've seen two runtime errors, and before I present them, let's talk about a runtime error. A runtime error is an error that takes place when the program is in run mode. It is running, which means the program has already successfully compiled. So the compiler did not find any syntax errors, and so we now have a program that appears correct. It runs and accepts input. So the two possible runtime errors that we've seen so far: divide by 0 and an invalid cast, trying to cast a text character as an integer, etc. So runtime errors result when Visual Basic throws what's called an exception. And it is an unhandled exception, which means the program doesn't know what to do. We have to talk about exception handling that a programmer, you the programmer, needs to build into your program, so it allows a program to fail, I love this, fail gracefully and recover if possible. In other words, to handle the error or the exception, and in most cases provide a recovery and some sort of notification to the user that an exception has occurred. Visual Basic provides exception handling in the form of the try-catch statement. And the syntax is try, and then you have a block of statements in between the keyword try and the keyword catch. And those statements may throw an exception. And then after catch, and in between catch and the keywords and try, you have a block of statements that will execute if an exception is thrown during the try block statements. So the code in between try and catch is the code that may throw an exception, may cause an error. There may be a possible divide by 0 error based upon input from the user. Now, we could talk at length about that happening, because that should never happen in a well-designed program. If a variable is a denominator in a calculation, you should, and that variable receives a value from user input, you should have checked that to make sure it's not 0 long before you get to try catch with that in there. But we'll get there. I promise we'll get there. So the try block contains program statements that might throw an exception, and the catch block contains statements to execute if an exception is thrown. Let's take a closer look. So here we have some code that shows a real-life example of exception handling. So in between try and catch are 2 lines of code and 2 comments. And we're going to try to cast the text property of text salary and convert it using CDEC to a decimal, and then assign that to the variable decimal salary. So let's assume the user enters into text salary, say it's an input box, enters a non-numeric character. Let me think. Instead of $10.50 per hour, they enter 10.10, the letter O, not the 0.50. Well, in that case, the function CDEC tries to convert a non-numeric value, and it throws an exception. And if that happens, then the code in the catch block in between catch and end try is executed. So when CDEC, in this case I just explained or described, when CDEC throws a cast exception, the try block catches it, jumps to and then executes the catch block, which displays an error message to the user try again and enter a number. Moving right along, now we're going to discuss the content of section 3.8 from your textbook, which I'm sure you've already read at least 3, 4, or 5 times before this lecture, because that's what college students do. They read the textbook before the lecture, so they're intimately aware of the content that will be lectured upon. Sorry. Let me get off my soapbox and let's get moving on the content of 3.8. The next topic I want to cover is the Tablndex property. And wow, does this slide have a lot of text on it. What I've done, Tablndex property is the order in which, when you hit the tab key, the focus jumps from one control to the next. And that's set by the Tablndex property. Rather than try to explain this, I've created a video. I want you to stop right now. Create a short tutorial video on Tablndex. It's a lot easier for me to demonstrate this than to try to explain it in an audio lecture. So stop right now, go to the timeline session, you'll find that, and take a look at it, and then come back. Okay, see you in a little bit. Bye. So, welcome back. How'd you like that tutorial? I'm sure you watched it at least 3 times. Haha. So, after watching that, you probably now understand what focus is, if you didn't understand it before. And so, for a control to have the focus means that it's ready to receive the user's input, and there's usually a cursor right there. In a running form, at any given point in time, only one of the controls on the form has the focus at any particular point in time. And it's only controls that are capable of input that may have the focus. So if you want to change or set the focus with text, there is a method called focus. So if I wanted to change with code, I wanted to change the focus to the text username control, I would use the following line of code right there at the bottom, text username.focus, and there are no arguments on that particular method. When a text box has focus, you'll see a blinking cursor, or its text will be highlighted, and when a button, a radio button, or a checkbox has focus, you'll see a thin dotted line around that particular control. And remember, only one control on a form has the focus at any given point in time. I'm sure you've seen programs that have what I call keyboard shortcuts or keyboard access keys. So let's just say you want to put a keyboard shortcut to a button with the text exit. So its text property is capital EXIT. Okay? We can allow the user to activate the button using Alt+X instead of left clicking with the mouse. And the way you do that, and it's a very cool feature, is you just put the ampersand before the letter in the text property. So in this particular case, the text property would be capital E ampersand XIT. And the character following the ampersand, and in this case it's the X, is the Alt or access key. You want to be careful not to use the same access key for 2 different buttons, because that will cause a problem. The ampersand has special meaning when used in the text property for a button. And you'll note that in this example, you'll see the text property for btnExit displayed as capital E ampersand XIT. Yet, the ampersand does not display in the text. Okay, it just simply establishes the Alt key access. So if you want to actually display an ampersand on a button, it must be entered as 2 ampersands together. So let's say we have button text save and exit is entered, or that you want save and exit to be the text on the button. You have to enter the text property for that button as save ampersand ampersand exit, as you see in the last part of this slide. And you can see what the button would look like at the bottom of the diagram on this slide. On to more GUI or graphic user interface elements. There is a property called the accept button property, and that designates which button on the form will be activated if the user hits the enter key. And it's the button clicked most frequently on a form is usually assigned as the accept button. Maybe OK. It may be yes, it may be enter, etc. Conversely, we have the cancel button property. Cancel button is a button that is activated if the user hits the escape key. Any exit or cancel button in a form is a very good candidate to become the cancel button. Tutorial 3-5 provides examples of setting access keys, accept, and cancel buttons. And I'm going to ask you to complete tutorial 3-5, and I will put a video of 3-5 running in the timeline. Next, on to the GroupBox Control, which I touched upon earlier with tab order. So a GroupBox creates a grouping of controls, and those controls are enclosed in a box, and the box has a title. And the controls within the GroupBox are related in several ways. They have their own tab order within the GroupBox. When you move a GroupBox, all the controls move with it. And if you remove a GroupBox, you also remove all the controls within the GroupBox. So be careful in deleting a GroupBox if the controls, if you don't want the controls to go with it. This slide describes how we place controls within a GroupBox. Obviously, the GroupBox has to be created first. Then you left-click to select the GroupBox control. And there's 2 ways you can place controls into a GroupBox, both of which are done from the toolbox. You either double-click the tool and then move it into the group, or you just left-click it and drag it from the toolbox into the GroupBox. That's my preference, but not necessarily the easier or better way to do this. If you want to move an existing control to a GroupBox, you just simply cut it and then select the GroupBox and paste the control into the GroupBox. I mentioned this earlier, but it deserves restating. A GroupBox has its own place in the Forms tab order. And once the tab order reaches the GroupBox, all of the controls in the GroupBox have a tab order within that GroupBox. So here we have on the lower right-hand corner of this slide a GroupBox, and it's second in the Forms tab order. And the tab order of controls in the GroupBox is 3, 4, and 5. you can select multiple controls and then act upon them as a group. And I don't mean a group box. You can click and drag over the desired controls, and that creates a kind of a window, and any of the controls within that window, even if they're partially in the window, they get selected. Or you can hold the control key and then continue to left click controls individually and add them to the group. And once again, not a group box. Okay, this is a selection group. And once the controls are grouped, they can be moved, they can be deleted, or you can set the properties of all of the controls that you just selected in a selection group. That's very useful. And once again, I mean, I can talk about these things until I'm blue in the face, but you need to try these in the tutorials. Next, we're going to cover the contents from section 3.9 in your textbook, the load event. Ta-da! This happens when you load the form. When the application first starts running, the form is loaded, and then we're off to the races. If you recall, when you're in design view, if you want to see the code associated with any of the controls, you double click on the control. Well, to see the load event handler, move to any empty space on the form. Remember, you're still on the form, and double click, and you'll see the load event handler. And if you want code to execute when the form with all the controls on it first loads, you place the code between private sub and end sub lines of the event handler. Here we have an example. The programmer wanted a message box to display the message, prepare to see the form. Give it a try. The next section, which is from 3.10 in your textbook, is a series of assistance slides for the room charge calculator application. I've assigned this as a regular assignment, even though it's a tutorial in your textbook. I want to make sure that A, you follow this section in the lecture, and B, you follow the instructions in the textbook and finish the room charge calculator application. It pulls together much of the lecture topics for chapter 3. So let's get started. One of the biggest mistakes many students make in their programming learning experience is to immediately try to start coding. Throw a few controls on the form, start coding, and before you know it, what sounded like a shortcut actually takes significantly more time and causes a lot more frustration. What we have here is a sketch, a very nice sketch. I'm not the best artist, so this would be a really nice sketch if I had done it. Probably need a straight edge. But we have the groups of controls on the form. You see text box, text nights, and text nightly charge. You've got labels for today's date and time and the control names that the author suggests you use. You have 3 text boxes for room service, telephone, and miscellaneous. You have your total charges group box and 5 controls in there. And you have 3 buttons, button calculate, button clear, and button exit. So this would be an excellent step 1 in visualizing the form and all the controls as they're going to exist on the form. Next, the author shows a nice flow chart for the events, or the sequence of events, for the btnCalculate click event. So you calculate the room charges, you multiply the number of nights by the nightly charge, and you store the results in the variable decimal room charges. You assign the value in decimal room charges to the label, the text property of the label room charges. You calculate your additional charges. You add your room service, telephone, and other charges, and you store those results in the variable decimal add charges. And then you assign the value stored in decimal add charges to the text property of the label add charges. Then you calculate your subtotal. You add the variable decimal room charges to decimal add charges, and you store the results in the variable decimal subtotal. Then you calculate the tax by multiplying the subtotal by the decimal tax rate and store the result in decimal tax. Most students get screwed up here. This is not the total. This is just the tax that gets added to the subtotal. Okay? You assign the value in decimal tax to the text property of the label tax, and then you calculate your total charges by adding the subtotal and the tax, and you store the result in the variable decimal total, and then you assign the value in decimal total to the text property for the label which will display it, which is label total. And that is the end of the flow chart for btnCalculate. The flow chart for the btnClear event handler is less complex. There's not as much going on. So first thing you want to do with that event handler is you want to clear the room information fields. So you simply store an empty string in the text properties for those two text boxes, text nights and text nightly charge. You want to clear all the additional charges fields, okay? So once again, you store the empty string in the text properties for room service, telephone, and miscellaneous charges. You want to clear all the total fields, so you want to store an empty string in the text property of all the room charges, additional charges, subtotal, tax, the label tax, and the label total. You want to reset the date and time fields, so you want to store the system date in the text property for label date today and label time today. And then return the focused to text nights control, okay? And our tab order will start over from there. Next up, we have a flow chart for the exit button, and also for the load event. Pretty easy. btnExit, you want to terminate the application by closing the form, and for the load event, you want to retrieve the system date and store it in the text property for the label date today, and you want to retrieve the system time and store it in the text property for label time today. Here we have a screen print of the completed form, and it looks very similar to that sketch, as it should. There is an aesthetic part to this, the creative part, that doesn't necessarily dictate that this form as set up in this slide is the perfect or the only solution. It's a very good and well-organized solution, but that doesn't necessarily mean that another form design with things moved around a little differently wouldn't be as efficient and as correct. So that's the artistic part of graphical user interface programming. On to another artistic or aesthetic topic, which is the color palette that you choose to use. You can change color properties with code and make a more artistic, creative, stylish user interface. Here's how you change a label's background color, and it's foreground color. Label message.backcolor equals color.black. Label message.forecolor equals color.yellow. And then there's some code that returns the background and foreground to the default colors, system colors.control and .control text. Tutorial 3-11, which I strongly suggest you complete, demonstrates how to change a label's colors with code. Okay, last topic for chapter 3. I'm almost done with you, or you're thinking we're almost done with him. Let's talk a little bit about debugging logic errors. Most likely, some, if not all of you, will have some errors in your program. It happens. And the problem-solving process that then ensues is very valuable. In fact, I'll go as far to say, as the programming problem-solving skills you develop in this class will serve you way beyond the scope of this class. They are great cognitive skills to hone, and programming helps you to do that. So anyway, you have a program, and it runs, but for some reason it's not correct. It has logic errors. And you've run the program with various inputs, and you've not yet been able to isolate where those logic errors lie. What do you do next? Here are a couple suggestions. I love breakpoints. A breakpoint is a point in the program. You select it in your source code, you insert a breakpoint, and when execution reaches this line, it pauses. And in the variables window, you can examine the value, snapshot view of all of your variables and certain control properties. And you can also single step through the program, which executes one statement at a time. So you can see in slow motion, one statement at a time, what's happening. And in most cases, you'll use this tool and find the logic error. Oh, I assigned the wrong value, or that equation, that calculation is incorrect. And you'll use the watch windows to see what various values are stored in the data elements, in the variables that you've declared and are using in the program. These are extremely useful tools. We're going to continue to talk about breakpoints and watch windows and single stepping. And so this is the point at which you should not just say, okay, I'll think about that later. You should stop, take one of the tutorials you've already worked on, maybe 3.10, 3.11, and you should set a few breakpoints, okay? Execute the program, watch it, get to that breakpoint, look at the local variables window, and see where all the data is. See where the values, the input values were used to initialize variables, the calculations in the program, changed the variables or initialized new variables. This is an extremely valuable process for you. If not, you're trying to debug something without really seeing its inner workings. Here's a slide showing the toolbar for the debugging commands that we just discussed. You know, the right arrow, start or continue debugging. You've got to stop, step into, okay, step over, and step out of. Let's talk about that. Step into, we'll step into the next line of code if it's a subroutine, which we haven't really described in depth, but if it is a subroutine, it will step into it, and then you can step into it one step at a time. If you're using step over and you get to a line of code that calls a subroutine, it will execute the entire subroutine and step over it. If you're in if you stepped into a subroutine and you see you've got many steps to step out into the function that called it, you can step out and it will finish executing the subroutine and step out to the line after where it was called. All extremely useful that you should start playing around with, experimenting with. Not playing, we're not playing here, this is serious. You should, just kidding. You should start experimenting, playing around with these features. They will make the learning experience so much less frustrating.